kidding, telling you.
Hello everybody, it's me, Shapez, this guy, this funny little man. Yes, it has been 4 months, yes, school has been stressful, but mainly I've just been lazy. Anyway, let's get on with the video. In this video, guess what we're gonna be doing? If you guessed that we're going small, you guessed right, my guy. Good job. So of course, as per usual, for this video, we're gonna switch into our Shapez robot outfit. FBI, open up! Even though we're not gonna be using it very much.
Emotional, damn it!
Let's start off with the basics. The average human. The average human male height is roughly 5'7", which is, good. Good average height. Good, today's world might not accept that height as good, but, we'll accept it as the baseline. So, Shapez robot, a little bit taller than that. I don't know. That was just how I drew him. So, first thing on the list, hummingbird. This is supposed to be a hummingbird. Yes, I suck at drawing birds, but that's besides the point. Anyway, a hummingbird is about 10 centimeters, which works out to a perfect 1 times 10 to the power of -1 meters, which is a very good starting point. Fun fact about hummingbirds is that they flap their wings 12 to 80 times per second, which is nuts. On the tip of Shapez robot hand, we have a grain of rice, which is about 5 millimeters. Let's just say rice is surprisingly tiny, but we're also not even close to done yet. On the tip of that grain of rice, we have a silt particle, which is 50 micrometers, and that's silt. I believe, according to my limited knowledge, that that silt is the kind of stuff that, like, when you put your feet on the bottom of a river, that's the stuff that kicks up. And that stuff is 50 micrometers. That stuff is crazy. But yeah, this stuff fits on the end of a grain of rice, no problemo. And even further still, we have the largest virus, which is 4.4 times 10 to the -7 meters, which is 440 nanometers. And funnily enough, even though this thing is so tiny, this thing's name is Megavirus. This thing is micro, but its name is Mega, which is hilarious. But yeah, on the tip of one of these viruses' tentacles, we have a strand of DNA, which is the thing that makes you, you. Aren't you? Yes, and we love the you, because you are perfect. I'm just kidding, nobody's perfect, but you're pretty close. Which is 3 times 10 to the power of -8, which is 3 nanometers. Which is absolutely nuts. Anyway, let's continue. On the end of one of these DNA strands, we have a hydrogen atom, which is 3.1 to the power of -10, or 3.1 times 10 to the power of -11 meters, which that is 3 orders of magnitude smaller than a DNA strand. I don't know why I drew the DNA so big here, but that is 31 picometers, which is absolutely crazy. But on the scale of the universe, we're not even halfway down yet. Here we have a great silence. Not the greatest, not like the great silence itself, because that will come up later in the video. But this is a great silence in and of itself, where we go down another 4 orders of magnitude, where we meet the proton and the neutron, and we also meet the surprisingly bigger than the proton and neutron electron, which is surprising to me because I always imagined electrons being really small, but they're actually bigger than the proton and neutron. And now, even further still, also, the proton and neutron are the same size. They are 1 times 10 to the power of negative 15 meters, which is 1 femtometer. And then the electron is 5.64 times 10 to the negative 15 meters. Oddly specific, but welcome nonetheless. And now we go down to quark level. And funnily enough, the two quarks we're talking about here still aren't even halfway down. The quarks that are talked about here are the up and down quark, the most common type of quark, and the ones that are usually found inside of atoms. The protons and neutrons break down into these. They are 1 times 10 to the power of negative 18 meters, which is 1 attometer, which is so unbelievably small that we didn't even think these existed until we smashed atoms together really hard. And who knows, maybe one day if we get the technology, we'll be able to smash these together really hard. And according to our science, these shouldn't break down. But if they do, we'll have a whole nother layer to study, which, just in my opinion, would be really freaking cool. Down a little bit further, only 2 orders of magnitude, so not bad, we have the bottom quark. Funny name, but yeah, it's 3 times 10 to the power of negative 20, which is 30 zeptometers. And just a little bit smaller than that, we have a high energy neutrino. Now, neutrinos are weird because they are so small and so common, yet they don't interact with anything. One funny story about a neutrino is supposedly during a Mario 64 speedrun, a high energy solar neutrino blasted from the sun, traveled all the way through Earth, and interacted with a singular bit in an N64, and that caused Mario to go up into it caused him to alter the jump height, or like the y-axis of where Mario was, and so he zapped above some place he wasn't supposed to be yet. And yeah, it was crazy, like a 1 in, I don't know, however much chance, but that is half the size of a bottom quark. Probably not drawn to exactly half the size, but it's close enough. Now, further down still, we still have another quark. We have a top quark, all alone, chilling in his little space. Look at him. He's just hanging out with 1 times 10 to the power of negative 22, which is 100 yoctometers, which is unbelievably small. And now, the last thing before the great silence is a basic neutrino. The one we had earlier was a high energy neutrino, but what if we just have a neutrino with little energy, or no energy? This is exactly 1 yoctometer, and it is 10 to the power of negative 24 meters. Also, a fact that I didn't say before about neutrinos is if you look at your hand, there are literally trillions passing through like just your thumbnail. It's nuts. But now we have the great silence, or what I call the part of, because I'm using an app to get all these things, it's called Scale of the Universe 2. And on this website, there's a massive gap between a neutrino and then the smallest thing in the universe, or supposed smallest thing, I should say. So let's dive down into the deep world of the smallest in the universe. Here are the 3 things that are all similar sizes, but only one can be the smallest. And that is the Planck length. This little guy in the middle here, the guy looking like the main attraction. He is the smallest thing in the known universe. Well, not even known, the speculated universe. This is the theoretical smallest measurement that can exist ever. These 2 things are just happen to be this small. The quantum foam is supposedly the foam that allows gravity to work. Pretty sure. Yeah, space-time theory. It's basically the stage that the universe plays out on. And exactly one string from, or actually, yeah, the quantum foam is this, not the string I pointed to earlier. That's the quantum foam. That's the stage it plays out on. And let's imagine one board of that stage. That is what we call a string, which is a singular fiber of the quantum foam. Both interact with theoretical things and allow things to have gravity and mass, like the sun. Like, imagine the sun is, like, imagine this is the quantum foam. Place something with a high mass, like the sun, over it, and we get a shape like this, which coincidentally solves the problem of how can the universe come from nothing? And it is theorized that the displacement of the quantum foam equals out, equalizes the thing, the mass difference, or like the mass that just supposedly came out of nowhere. And so now we have this big thing that supposedly came out of nowhere, displacing its mass and energy into the quantum foam. And so that's a theory of how the universe works. Down here is also probably the string is also from string theory. The string is what makes up string theory in its like entirety. Singular strings vibrate at different frequencies to make different atomic structure, or atomic what's it called? Atomic somethings. The really, really tiny particles, like gluons and stuff. Gluons, the stuff that holds quarks together. Yeah, like the thing that makes string theory so special is that one of these strings vibrating at a certain frequency might produce something called gravitons. And marrying the theory of gravity to the theory of the standard model would create a theory of everything. And that would be an incredible accomplishment for humankind. But yeah, I think that's about going to do it for this episode of Shapes' late upload. Woo! I stream a lot. I've slowed down because school's been stressful, but I stream at Shapes Animation. I think, yeah, there's no S there. Go subscribe to my editor, Lunar Nights YT. He's the best. Feel free to plug yourself if the intro's not going off. What else can I plug? I will hope to upload in another month, but if I don't, sorry, no promises. I don't know, some updates on my life since I've been on. I've started drawing comics. I've gotten into anime, so now I draw comics, or manga, air quotes, like a weeb. But yeah, that's basically what I've been doing. Anyway, I'll catch you guys all next time.